In this video, I want to look at another example of how we can patch up a U substitution through the idea of inverse substitutions. In our textbook, the authors have an example that says, find the integral of dx over 1 plus the square root of x. Now, the first thing that I'm going to do is I'm going to rewrite this integral as 1 over 1 plus square root of x dx, because I prefer the dx out here all by itself. And I want to analyze the integrand. If I look at the integrand, it's 1 over junk, but I do not have the derivative of the junk inside this integral. And so I know that if I try and make u equal to 1 plus the square root of x, I'm going to have some real problems with making everything work out. Now, if I try to make u equal to just the square root of x, I still don't have what I need for du, but at least I'll be able to try to solve for x in terms of u, and I might be able to solve for dx in terms of du. So that's what I'm going to try and do. We're going to let u be square root of x, which can also be written as x to the 1/2. Then du is going to be 1/2 times x to the minus 1/2 dx. And I can clean that up. Du is equal to 1 over 2 times the square root of x times dx. Now, what I want to do is I want to realize the following things. I can certainly put in u for the square root of x right there inside my integral. But what I want to do is I want to see what should I substitute for the dx. And I'm going to base that on this particular equation. So I want to solve for dx in terms of du. Well, that's not too hard. All I'm going to do is multiply this equation by 2 times the square root of x on both sides. And on this side, of course, they cancel out. And on this side, I get 2 times the square root of x du. In other words, what I've got right now is that dx can be written as 2 square roots of x times du. But I would really like to have dx in terms of u and du. So I'm going to squish up here u and du. But I happen to already know that the square root of x is just another name for u. So I can rewrite this as dx is equal to 2u du. And what I want to do is I want to circle in this and this, because these are the two things that I'm going to substitute into my integral. And when I do the substitution, I'm going to have the integral of 1 over 1 plus the square root of x is equal to u, so I put a u in there. And now I'm going to come down here and get this thing here for dx, and dx is nothing more than 2u du. And I can clean this integral up, and it's 2 times the integral of u over 1 plus u du. And at this point, I want to say we've looked at this one. We looked at this in the last video. And I kind of want to do this fairly quickly because I did it in a lot of detail over there. I need a new variable, and I am going to call this new variable v. So we are going to let v be 1 plus u, and dv then is du, and using this particular substitution, we can rewrite this integral as 2 times the integral of, well, let's see, v minus 1 is equal to u, so we have a v minus 1 upstairs over a v downstairs dv, and this wound up being equal to 2 times the integral of v over v dv minus, and I'm going to actually put in big parentheses here because the 2 is going to multiply everything, minus 1 times the integral of 1 over v dv. And so I get 2 times, well, this integral is just going to go back to v, and that one goes back to the log of v. And then I have any constant that I want to have. And now it's just a matter of back substituting. And let me go through that fairly carefully. V is equal to 1 plus u. So what I've got at this point is 2 times 1 plus u minus the log of 1 plus u, plus any constant that I want to add. And now, of course, I need to think about what is u, and I have to scroll back upwards. And what is u? U is the square root of x. So I put that in, and I wind up getting 2 times 1 plus the square root of x minus ln of 1 plus the square root of x, plus any constant that I want to add. Now, this parentheses are important, and I do want to say that if we carry the multiplication out, our final answer is going to be 2 plus 2 times the square root of x minus 2 times the log of 1 plus the square root of x plus a constant. So the integral that we started with, which was 1 over the square root of x dx, is equal to this particular thing.